Alright, let's do a few more examples. Again, we're just continuing on with the order of operations. In this example, we have division and subtraction. Division comes before subtraction in the order of operations, just to remind you that PEMDAS, the M and the D come together, the A and the S come together. The subtraction comes after the division, and so that means we need to do the division first. 12 divided by 2 is 6. 12 divided by 6 is 2. And so I replace this with a 2. Then I have 2 minus 2, which is 0. Now, with PEMDAS, one thing I said about the parentheses, this is, I said the P stood for parentheses, but really this is all grouping symbols. And I didn't really want to bring up grouping symbols quite yet, but we're about to see our first grouping symbol. This division bar actually acts as a grouping symbol. You can pretend there are parentheses whenever you have the division bar like that. You can pretend there are parentheses around the top and around the bottom. And what that does is it elevates the priority of any operations up there and any operations down there, and it means that division actually ends up taking place at the very last thing. So since we know it's going to take place at the very end of the problem, that means we can do all this other stuff. We can actually kind of do it separately. And this problem, it's kind of silly to split it up as two separate problems because there's nothing to do on the top part of this. But 12, well, that's just 12, whatever. Like I said, it's kind of silly to do. But because we know that that division isn't going to take place until the very end, I can just look at the base, the top separately and the bottom separately. 6 minus 2 is 4. So now I put it back together and I get 12 divided by 4. 12 was what was on the top, 4 is what's on the bottom. Then I put it all together and then I can actually perform that division. I get a 3. 12 divided by 4 is 3. That sort of pattern is actually handy to notice whenever you have higher priority operations. So if there were actually operations up top and down below, higher priority operations separated by a lower priority operation, you can work on them simultaneously. I'll point this out as we see examples. Alright, so let's see. Let's look at this one. I'll write this out so I can remember. It looks like we have multiplication and division. We have multiplication there, and we have division here. And then we have an addition separating them, right there. So the multiplication and the division are higher priorities than the addition. This is actually exactly that case that I was talking about up there. We have higher priority and high priority separated by a lower priority. This addition is going to happen after both of those are resolved, which means I can work on this part and this part simultaneously. So I can do this part is 6. 2 times 3 is 6. 6 divided by 2 is 3. And I can, since that addition isn't going to let them communicate until all those operations are completely done, I can do them in the same step. When I say simultaneously, I mean in the same step. And you're not going to run into issues here. And generally, people won't even be annoyed at you for doing multiple things in the same step here, because we're, 2 times 3 is 6. You can see what's happening there. 6 divided by 2 is 3. That's happening there. And we have the addition, which we can then resolve. 6 plus 3 is 9. Now, this would be as opposed to if we had something like this. So I'm doing 2 steps at the same time there, but it's not really causing a problem. What would cause a problem is if I did 2 steps at the same time like this. 1 plus 2 plus 3. I probably wouldn't want to, well, this is, I don't know, that's a simple enough question, but just to demonstrate the issue here. If I was to do these individually, I would do 1 plus 2, which is 3. So there's a tie between my additions here. So I'm going to do the one on the left first. 1 plus 2 is 3. And then I get 3 plus 3, which is 6. If you do 1 plus 2 plus 3 and do both of those additions on the same step, you're kind of modifying these two numbers to become a 3 and then modifying it again to become a 6. That might be a little confusing doing multiple steps there. That's a bad example. Let me just ignore it. All right. Let's see. Here we have a division bar, which, remember, this acts as a grouping symbol. So we can put parentheses around the top and parentheses around the bottom. Now I have this situation where I have high priority up top, high priority down low, and then a lower priority division that's separating them. Normally division comes before addition, but because of these parentheses, because of the division bar, really, this addition is going to take place first. So 8 times 7 is 56. 1 plus 3 is 4. And I'm able to do those in the same step because we have that pattern happening. Then I have 56 divided by 4, which is, what, 14? And I can give my answer there. You can really save yourself a lot of time if you learn to recognize when we have that pattern happening. Also, I want to point out, you have to be careful when you plug in something like this into the calculator, because the calculator doesn't generally do division bars. If I was to just type this in, kind of a, let's call this a naive way of doing it, if I did 8 times 7 divided by 1 plus 3, you might be able to look at this and say, okay, well, yeah, sure, there's the division there, and you know, I should do that first and whatnot. But this calculator doesn't know that. This calculator is just going to follow the order of operations as it stands. You can see it gives us a 59. It's a different number. Let's figure out what happened there. So the calculator sees this: 1 plus 3 or 8 times 7 divided by 1 plus 3. This is what the calculator sees, because that's what we just typed in. Well, the calculator doesn't see any division bar, doesn't see any parentheses or anything like that.
Message from Kimberly.
Which means that it's just going to do, between the multiplication and the division here, it's going to do the leftmost operation. It's going to do 56 divided by 1 plus 3. It didn't have that same sort of high priority operations separated by a low priority operation that we had. Alright, at this point it would then see that it needs to do the division. 56 divided by 1 is 56. And then 56 plus 3 is 59. That's where it got the 59 from. Again, the calculator is doing the correct thing. The problem is that we didn't type in the correct thing. If we wanted the calculator to do this using the division bar, we would need to actually manually put in these parentheses. So we would have to type it in like this. We would have to do parentheses, 8 times 7, close parentheses, divided by, open up other parentheses, 1 plus 3, close them. And then the calculator would actually be able to interpret this as a 14. You want to be very careful when you're taking a division and typing it into the calculator. This is a very common mistake that a lot of people make. You know, especially, this is not just a question of doing it right now. This is going to pop up again and again throughout the semester. Whenever you're typing stuff written as a fraction into the calculator, you need to be careful about that.